Hello student, this is your chapter number 6, Boolean Algebra and Logic Gate. See first what is Boolean is, here first of all correct the spelling, it is Boolean, okay. Boolean means that the answer should be either in true or false. Now this data type, true and false type of data is known as Boolean data type. Clear? Now true basically means 1 and false basically means 0. Now 1 and 0 are what? These are binary digits, okay, or in short it is known as bits, bits, okay. So there are some situations where we have to find the solution logically. We have to answer either on true or false, that today it will rain or will you go to school today. So such type of answer in this is either in yes or no, that is true or false, okay. So basically it will function, Boolean algebra functions on the values of true and false, okay. Now algebra is the mathematics that is based on Boolean value, is known as Boolean algebra, and it was basically developed by George Boole in the year 1854. He developed this symbolic logic which became useful to solve logical problems in mathematics and is known as Boolean algebra. Now Boolean algebra deals with either of two values, that is true or false. True means 1 and false means 0. Either the power is there or the power is not there. If the power is there, it will represent as 1, and if it is not, then it will represent as 0. Clear? Now in the year 1938, Claude Shannon developed a practical approach of Boolean algebra by applying in signal diversion, okay, through an electronic telephone. He used relays in the circuit to show the application of two-stage switching on and off process of relays, and this is the reason why Boolean algebra is also called as switching algebra, okay. And it really they produce a revolutionary change in the field of electronics engineering. Scientists realized the importance of application of Boolean algebra in computer electronics. Now we come to truth table. Now it is a tabular structure which shows the input values and the output obtained through any logical process. For example, if we take the example of AND operator, okay. Now see, AND operator is a binary operator. It works at least on two operands, A and B. Now this is the section for showing A dot B. So AND operator is basically a multiplication. So first we will take the possible combination of input of 0 and 1. First is 0 0, then 0 1, 1 0, 1 1. Now since it's a multiplication, so 0 0, answer will be 0. 1 into 0 will be 0. Again there is a 0, so it will count 0 only. Here both input is 1, so it will be 1. So this is the final. So the way we are representing it in the tabular form, in the table form, so that is why it is called truth table, okay. Now let's see the binary valued quantities, okay. Now what is this binary value? The same thing, if the solution or the outcome or the result of any logical statement is either yes or no, then or true or false, then it is called the binary value quantities, okay. Like, did you go to school? Will it rain today? Okay. Next is, each statement shown above is, the answer will be either 0 or 1. Now let's take what is Boolean variable. Just now I showed you the truth table, A, B, whatever inputs you are taking, that you represent in variable, okay. So that is called Boolean variable. Now what is a Boolean variable? Is similar to any variable used in algebra mathematics. A variable can be assigned any decimal number, but a Boolean variable contains either 0 or 1 only, okay. Now hence a Boolean variable is also termed as binary valued variable. Why binary valued variable? Because you just saw in the truth table the input was taken binary digits only, that is 0 and 1 combination only. So that is why it is called binary valued variable, okay. Now the syntax is binary valued variable is equals to binary valued quantity, like a is equals to 0, b is equals to 1. So we have to take the value either as 0 and 1 only, no other values, okay, to be taken. Now next is logical operator. Now what is this logical operator? Logical operator deals with only 3 types of logical operators: not, and or. Okay. Now logical not is a unary operator. Unary means it works on single operand. Okay. Basically this logical not, what it does, it will just reverse the input value. For example, if the input is A0, so A naught, the sign for not is used either this, it is also known as A complement, or you can put a bar sign on top of the variable. Okay. Like you see here, this is the bar value and this is the complement sign. Okay. So it is both means logical not. So it will reverse the input value. So for example, A is the input variable. Now its value is 0. So since not operator is applied on this, so what it will become? It will become 1. If suppose here it is 1, so it will change it to 0. It will just make it inversely proportion. That is, it will just reverse the output. So it works just like your inverter. Inverter, what it does? If an input is 0, then output will be 1. And if the input is 1, then output will be 0. That means if the power is there, then no light will be on, switched on through inverter. It will become 0. And if the power is off, the input is off in the inverter, so what happens? The entire whatever light is being connected to that inverter, that will turn on. That is, output will be 1. Okay. So this is what the use of not operator. You can see the truth table also. Here it is written A and this is your A naught. Okay. So it works on unary operator, no use of second variable. Only on A it will function. Okay. If see it is 0, so it is A naught is doing 1 to it, and if it is 1, then it will become 0. So this is the truth table of not operator. Next we come to logical operator. Okay, logical or operator. Now it is a simple addition. It is a binary. It is a binary operator. That means it works at least on 2 operand. More than it can be there, but not less than 2. Okay. So here it is the truth table. You can see the symbol for OR operator is plus. So A plus B here means that you have to apply the rule of OR operator. This is plus is the symbol of OR operator. So you can see here 2 possible inputs are there. Okay, 0 plus 0, 0, 0 plus 1, 1. Since addition is there, 1 plus 0, again output will be 1. 1 plus 1, again it will be 1. Okay. That means it will, in OR operator, the output will be 0 only when both the input are 0. Otherwise, either of the input is 1, answer will be 1 only, because it is a addition. Okay. So you can see the truth table also of the same. Here in this section, you have to write the input value, like A here it is written and B here it is written. Fine. Now possible values of input are 0 0 first combination, then 0 1 1 0 and 1 1. This you have to learn the combination, and then output you have to give it on the basis of operator. Plus is there, so 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1. That means all is 1. In either of the case, input is 1, and if both are 0, so obviously it will be 0 only. It's a Venn diagram also, you can see A plus B. Next we have logical AND operator. It is used, a dot sign or period sign is used. Okay, AND is the simple multiplication. Just now I showed you the truth table also. 0 dot 0 means AND operator is being used. Okay, and 0 dot 0, 0. So since it's a multiplication, so any of the input will be 0, output will be 0 only, and if both are 1, then only the output will be 1. Okay. Now same we have the truth table of this. Here it is A, B, and operator. Again it's a binary operator. It works on at least 2 operand. Okay. And then A dot B. Now A dot B can also be written as AB. Okay. So here you can see the same 4 possible combinations are written, and then output is given on the basis of operator, that is 0 0. 0 is there. On the basis of this role it is being done. Okay. And this is the Venn diagram of AND logic. Fine. Next we have Boolean expression. Now what is Boolean expression? You can see mathematical algebra uses operators like plus, minus, multiplication, division, power, etc. to deal with mathematical functions. Okay. Now A plus B is there, m into n oblique c plus d. So first this c plus d bracket will be solved. Then what will happen? M into n will be done, and whatever is the result, that will be divided. Okay. So here you can see Boolean expression applies only 3 types of operators such as NOT, and OR. Propositional statement, that means it rains and you play football. So x and x in bracket x dot y. Either you read book or you go to bed, then x or y. Either is there, that means you have a choice between 2, or y of x plus y. Okay. Now you are selected, but you play cricket or football, not x and y or z, x complement dot y plus z. So this is how you get the Boolean expression. Okay. Next is framing Boolean expression. A Boolean expression can be formed by using Boolean variables, binary valued quantities along with logical operator. As you have x plus y, the algebra form, same way you can form the Boolean expression. Now p complement dot q, so dot is there, the AND operator is there, then plus is the OR operator, then p dot q complement, it is again AND operator is there and not sign is used, then plus again an OR operator, then p dot q whole complement. Okay. So whatever will be the result of p dot q, it will be complemented by using NOT operator. Then a plus a complement or b plus 1, and in this way you can see the various expression. In case dot in any expression missing in between variables, then it resembles the multiplication AND operator only by default. Okay. Now you can see here, next is drawing truth table for Boolean expression. So this we will cover in the next video, that is video number 2 of this chapter number 6. Okay. So till then, go through it thoroughly, revise each and every step, and operator, what is the use, how it is denoted, and how the truth table is formed for AND, OR, and NOT. Thank you children.